Can dangling pointers always lead to undefined behavior? Imagine working on a program and suddenly it crashes or behaves strangely. One common culprit behind these issues is a dangling pointer. But do they always cause chaos? Let's find out. A dangling pointer is a pointer that still holds the address of memory that has been freed or deallocated. For example, if you use the free function in C to releases memory, but forget to set the pointer to null, that pointer becomes dangling. It still points to that same memory location, even though that memory is no longer yours to use. Now, undefined behavior means the program might do anything, crash, produce wrong results, or even seem to work fine. When it comes to dangling pointers, dereferencing one usually leads to undefined behavior. That means if you try to access the memory through that pointer, your program could crash or corrupt data. But here's the interesting part. Just having a dangling pointer doesn't always cause problems. If you never dereference it, meaning you don't try to read or write to that memory, it might sit quietly without causing immediate issues. You could compare it, assign it, or pass it around, and the program might seem okay. Still, this is risky because the memory could be reallocated for other purposes later, causing unpredictable behavior if you do dereference it in the future. In debugging, spotting dangling pointers is vital. They are often the root of bugs like use-after-free errors, which are tricky to find because they don't always cause immediate crashes. Using tools like memory debuggers or sanitizers can help catch these issues early. For example, Address Sanitizer can detect when you try to access freed memory, making it easier to fix dangling pointers before they cause real problems. Preventing dangling pointers is simple but effective. After freeing memory, set your pointer to null. This way, if you accidentally dereference it later, your program will crash immediately, making the mistake obvious. Using smart pointers in languages like C++ also helps because they automatically manage memory and clear themselves when no longer needed. Some environments might handle operations on dangling pointers differently, but it's safest to assume that dereferencing them is always risky. The consequences can be unpredictable, and bugs caused by dangling pointers can be very hard to track down. So, to answer the question directly, dangling pointers do not always cause undefined behavior unless you dereference them. But if you do, the results are almost always unpredictable and potentially dangerous. That's why managing memory carefully and avoiding dangling pointers altogether is a key part of writing reliable, bug-free software.